recording. Okay, we will continue with chapter 1. Okay, so from the past, we already completed, okay, A, B, C, D, E, F up to binomial. Then we have a GFI left. Okay, GFI. So then from here, we have a modulus equations, okay, inequality and modulus inequality. Okay, so we have three ways to actually solve these questions. Either we actually can do it by square both sides, okay, by analytic method, or by graph. So by graph here, we can actually use test point method. Okay, then over here, so let's say for this question, 3x plus 4 equals to modulus of x plus 5. So over here, we can act this method 1. This is an analytic method. Okay, so because of the modulus itself, it can be positive sign or negative sign. Therefore, they split these questions into two. 3x plus 4 equals to positive of x plus 5, and 3x plus 4 equals the negative of x plus 5. Okay, therefore you have these two questions here. Hence, we have these two answers. In order to know whether which answer that we should accept, okay, we have to do checking. So when we do checking, does it fulfill the inequality? Does it fulfill with the modulus with the equation? Then we can actually tell. Okay, if left equals to right, then we accept it. If the left not equals to right, then we reject it. So this is an analytic method. So far, okay? Acceptable? Okay. Then we have method 2. This is a square both side method. Okay, square both side method. So it's the same questions. Modulus of 3x plus 4 equals to modulus x plus 5. Okay, then as you can see, we square both sides like this. Okay, so then we will actually get a quadratic equations. Okay, factorize. You will see that you will get the same answer. But the only problem here is, okay, after you did do this one, you also need to do checking. Okay, also need to do checking. You may need to reject some answers. Some answers may not be fulfilled with the questions. You have to aware. Okay, it may not fulfill with the questions. So this will be the analytic method and the square both side method. So if I really want, can I actually do it by graph? Okay, we can actually do it by graph by drawing out the graph. So I let y1 equals to modulus of 3x plus 4. I let y2 equals to modulus of x plus 5. Okay, then I draw the graph. Okay, for easy illustration, I use one as the blue color, another one as the red color. Okay, then I draw the graph. For the blue color, I get a 4 and like this. 4 and negative 4 over 3 like this. For the red color, okay, this is the, in front of the x is 1, therefore it will be flatter because the gradient is smaller. So although it passes through 5, okay, but the is flatter. Okay, so you will see that you see two intersection point where this is a 5, this is a minus 5. This is two intersection point. Okay, so by graph, we can actually try to solve these two equations. You'll realize that one is 1 over 2, and the other answer is negative 9 over 4. Therefore, these are the two answers. If you do it by graph, acceptable. Okay, so of course over here we will also assume students are capable of doing all of this graph drawing. Okay, we will assume students okay with the drawing the graph. Okay, next example. I have a modulus of x plus 3 plus modulus of x plus 5 equals to 10. Okay, over here. Okay, for this type of questions, square both sides is useless. This is something that I need you to aware. The squaring both sides is useless. The better method, okay, better method is the analytic method. If we look at the equations of modulus x plus 3 plus modulus of x plus 5 equals to 10, we actually can split into 4 cases. Okay, we can split into over here. Although that the questions you only use 2 equations because they already know the answer, but students who actually don't know, there are 4 possible cases. Okay, so what are the 4 possible cases? Positive with positive, positive with negative, negative with positive, and negative with negative. So therefore, I will have the form of x plus 3. I will have the form of x plus 5 here. Again, regardless whatever type of questions, we consider the 4 possible cases. Whether you can actually get the answer or not late, it will be deal with them later. Maybe you have 4 different answers. Therefore, from here, I'm trying to solve for each of them. Okay, so 2x 8 2, so x equals to 1. Okay, for the first answer. Then this one, x minus x is gone, no solution. Okay, this one minus x plus x also gone, no solution. And this one minus x plus x minus 8, so x equals to 9, minus 9 for this one. After we do that, we still need to do checking. Okay, we still need to do checking. So how do we actually do checking? We substitute the 1 inside and the negative 9 inside to see whether it does it equal back to 10. So I have a modulus of x plus 3 plus modulus of x plus 5. I substitute with 1, 1 plus 3 plus 1 plus 5. So it gives us 10, correct. Then the second answer, I have a negative 9 plus, okay, the second one, x plus 3 plus x plus 5, substitute with minus 9 plus 3 plus minus 9 plus 5. Okay, so I will have a 6 plus 4, so also equals to 10. Then both answer is accepted. Are you okay? So from here, you have a bunch of questions that you actually can try. Okay, that you can actually deal with it later. Okay, so what about inequality? Okay, what about inequality? So other than the equation, you also need to deal with inequality because you have inequality questions. Okay, so over here, Let's go back to the first example. Okay, let's go back to the first example. Let's say I have the questions of modulus 3x plus 4 lesser than x plus 5. Okay, now we are talking about inequality part. The strategy is, okay, we solve equation first, we deal with inequality later. We tackle the equation first, we deal with inequality later. That means, whatever the question that you have here, you solve the equation first, then only we deal with the inequality. The only thing that for inequality, you just need to remember that the bottom cannot equal to 0. Denominator cannot equal to 0. Therefore, for example, there's an x plus 1 here, isn't it? So x cannot equal to minus 1. There's an x here, isn't it? So x cannot equal to 0. Because both of these will make the bottom goes to 0. Okay, those are the things that you need to remember. Back to these questions. This one has no denominator. How are we going to solve these questions? We already know the answer is half and negative 9 over 4. So I draw a number line for half and negative 9 over 4. Okay. This is the time we can use the test point method. This is the time that we can actually use the test point method. This is a number line that's separated into 3 parts. Sorry, I draw the number wrongly to the wrong side. The half should be on the right. The negative 9 over 4 should be on the left. Again, this one is a number line. Okay, this is a number line. The number line separated into 3 parts by these 2 numbers. Separated into 3 parts by these 2 numbers. More than half. In between negative 9 over 4 to half. And lesser than negative 9 over 4. So now, in order to fulfill this inequality, I take a random number from each sections. Let's say I take 10 from here. Let's say I take a 0 from here. Let's say I take a negative 10 from here. So 10, I put it back inside the inequality. I have 30 plus 4, modulus 34. 10 plus 5, so 15. If 15 greater than 34, no, it doesn't. So this one is out. I give it a cross. 0, I put it in. 3, 0 plus 4, so this is 4. 0 plus 5, this is a 5. Is 5 greater than 4? Yes, I give it a tick. Negative 10, I put it inside. Now, negative 10, negative 30 plus 4, negative 30 plus 4, negative 26. With the modulus, become 26. Okay, I have a 26 over here. Then after that, negative 10 plus 5, I have a minus 5. Modulus, I have a 5. Is 5 greater than 26? No, of course it's not. So I give it a cross. Therefore, my answer is negative 9 over 4 x to 1 over 2. Are you okay? Okay. Now come to these questions. What if this is also an inequality questions? So I have a modulus of x plus 3 plus x plus 5 lesser than 10. What if I have these questions lesser than 10? Okay, so from earlier we already drawn the number line. I have a minus 9 and 1. Okay, so I check the value. Okay, so this number line separated into 3 parts. More than 1, in between negative 9 and 1, and lesser than negative 9. Therefore, over here, I suggest numbers. So let's say I choose 10 over here, 0 over here, negative 10 over here. Then each of them I substitute inside to do checking. So I have a 13 plus 15. Okay, so 13 plus 15, so 28. Is 28 lesser than 10? Of course it's not. So this one is out. Then 0. Okay, I substitute 0 inside. 3, 5 is 8. Is 8 lesser than 10? Yes, it is. So I give it a tick. Negative 10, I put it inside. Negative 10, I have a 7 on over here. 5 over here. 7 plus 5, I have a 12 in total on the left side. Is 12 lesser than 10? Of course it's not. Therefore, I will have my answer as, okay, x is in between of negative 9 and 1 as my answer. So what I'm trying to tell you is the questions are actually together. Inequality and modulus. Modulus inequality. They are all together. Therefore, you have this type of questions. Okay. So in terms of illustration, I'm going to show you how am I going to solve for these questions. Okay. How am I going to solve for these questions? So let's say I use number 8 example. Okay. So this is an equality question together with the modulus. Okay. At the same time, we also assume that students are okay with the graph. Okay. So let's say I want to solve these questions. So I'm going to do let modulus of x over x plus 2 equals to 1 minus x. Okay. Because of the modulus, okay, I break that down into two questions. Positive of x over x plus 2 equals to 1 minus x. Negative of x over x plus 2 equals to 1 minus x. Then I continue searching, solving them. So I have x equals to 1 minus x, x plus 2, open it up, x plus 2 minus x squared minus x. So I have a x squared, bring it over, plus x minus 2 equals 0. Okay, then I have a x minus x plus 2, x minus 1 equals 0, x equals negative 2, x equals to 1. Then I have a second set of answer questions. So I continue with negative x equals to 1 minus x, x plus 2, minus x equals to x plus 2 minus x squared minus x. I have a x squared minus x minus 2 equals 0, x minus 2, x plus 1 equals 0, x equals to 2, x equals to minus 1. There are so many answers. Which one is correct? Which one should I take it into account? So I do checking. Okay, I do checking. I check for x equals to negative 2. So left hand side, I have a negative 2 over negative 2 plus 2. This one undefined. So you reject them. Okay, so x equals to 1. The left hand side equals to 1 over 1 plus 2. I have a 1 over 3. Right hand side. Okay. Right hand side, I have a 1 minus 1. If it's 0, different. Reject. Okay. Then I have x equals to 2. The left hand side equals to 2 over 2 plus 2 equals 1 over 2. Right hand side equals 2. Okay. 1 minus 2 equals to minus 1. Reject. Okay. This question is also rejected. This working also rejected. Did I factorize wrongly? Let me just check. Maybe I factorized wrongly. X plus 2, 1 minus x, 1 minus x plus 2, x plus 2 minus x squared minus x gone, x squared plus x minus 2. 1 equal minus 2 equal 1 and negative 2. Okay, this is 1 x 1 minus x plus 2, same thing. One equal minus 1 equal minus 2 equal 2 and minus 1. Did I make any mistakes here? X equals to minus 1, left hand side equals to minus 1 over minus 1 plus 2. I have 1, right hand side 1 minus minus 1 equals 2. Okay, definitely make a mistake there. Last part should be 2x. Oh, okay, definitely something wrong. Yes, thank you. So where is my mistakes? 1 times x, then minus 2x. Minus 2x. Okay, that's my mistakes. So x gone. This is a x gone. This is a 2x. So therefore over here, this is not a nice number. X equals to 1 equal, 2 equal, minus 2 equal, minus 1 plus square root 3, minus 1 minus square root 3, 2x, this one x squared, minus x, this is gone. This one is minus x minus 2x minus 2x all gone. So you have there this. So x equals 2 plus minus square root 2. Okay. Okay. So as you can see, this part, if you make an algebra mistakes, it's going to cost you a lot. Okay. Therefore, during exam, we will require students will be 100% no error over here. Like as you can see, I immediately detect that I already did it wrong when I do checking. then I know that I already made mistakes. That will be the ability that you need to have during exam. That you need to know how to actually check answers. So x equals to minus 1 plus square root 3. So left hand side, modulus of minus 1 plus square root 3 over negative 1 plus square root 3 plus 2. Okay, this one of course we press calculator. Okay, minus 1 plus square root 3 over minus 1 plus square root 3 plus 2. So 2 minus square root 3. Right hand side, I have a 1 minus 1 plus square root 3. So I have a 2 minus square root 3. Same. This answer is correct. X equals to minus 1 minus square root 3. Left hand side, minus 1 minus square root 3 over minus 1 minus square root 3 plus 2. So minus, I have a 2 plus square root 3. Let's see, right hand side, I have a 1 minus 2 plus square root 3. Sorry, 1 minus 1 minus square root 3. I have a 2 plus square root 3. Also correct, accepted. Okay, then the other answer, square root 2 and negative square root 2. X equals to square root 2, left hand side. Square root 2 plus 2. Press calculator. Square root 2 plus 2. I have a negative 1 plus square root 2. Right hand side, I have a 1 minus square root 2. Different. Reject the answer. X equals to negative square root 2. Left hand side, negative square root 2, negative square root 2 plus 2. Minus. This is a 1 plus square root 2. Right hand side, 1 minus square root 2 is 1 plus square root 2. Accepted. Among the 4 answers that we got, after doing checking, only 3 are accepted for these questions. Now comes to inequality. Inequality. I have a number line. Okay. This value, square root 3 minus 1, is about 0.7. Okay. This is about negative 2.7. This is 1.4. This is negative 1.4. Okay, but 1.4, this one is rejected, so it's not included. So I have a negative 2.7, negative 1.4, and 0.7. That actually give me negative square root 2, negative 1 minus square root 3, and negative 1 plus square root 3. There is another problem. The bottom cannot equal to negative 2. Add another limit where x over x2 bottom cannot equal 0. So I have a negative 2 somewhere. Okay, so this number line separated into 4 parts. This number line separated into 4 parts that I need to check answer for the 4 parts. So I will see. Okay, I use test point method. Test point. Okay, maybe this one with 1, this one is 0, this one maybe negative 1.5, this one maybe negative 2.5, this one maybe negative with negative 3. Okay, don't forget our equation of inequality is this. So I do my checking. 1. Okay, so modulus of x over x plus 2 1 minus 1 plus x. So calculate with 1. So this is a positive num. This is the left side lesser than the right side. This is greater than. Okay, so this is out. Calculate. So this one accepted. This one is no. This one rejected. This one less than this. This one is greater than this. Calculate. Negative 2.5. This is also positive. Then this is not. Then and calculate 2.5 negative 2 negative 3. This is accepted. Therefore, the answer is x is lesser than negative 1 minus square root 3 and negative square root 2 x in between of negative 1 plus square root 3 as answer. You have this. One whole questions, but you have a lot of thinking parts to do. Of course, also depends on the difficulty of P3, how difficult they want it to be. So this will be equations, inequality, okay? And again, if we want to, I can do by drawing, by graph. What if solving by graph? So I let y1 equals to modulus x plus x2. I let y2 equals to 1 minus x. So I do my graph. By using graph transformation, okay, x plus 2, okay, y equals to x over x plus 2. This is P1 graph. So you have a minus 2 here. Okay, when substitute x with the large number, so goes to 1. And it's 0, 0 here, and 0 here. So for the first graph, you have y equals to 1, x equals to negative 2, this is your y1 from graph transformation. Then what about your y2? 1 minus Drawing not so nice. Okay, this is my y2. So you may be questions, how do we know what are the points? The interceptions here. This is your -1 minus square root 3. This one here is the value of negative square root 2. And this value here, sorry, not that. And this value here, this is your -1 plus square root 3. In order to answer the inequality questions, that modulus of x plus 2 lesser than 1 minus x, this is the same as saying y1 lesser than y2. Okay, I better look at the black color. The black color. So which is the region that the black is below the red? The region that the black is over here and over here. That's the two answers. A lot of information, but you will be expected to digest it them slowly. It's just that it's not that difficult or what. It's just that it's not that about P3 or what. It's just that it's being more and more difficult when it comes to P3 questions. I don't know how many of you are still there. Although I'm doing recording here. Thank you very much. Okay. Because as you can see, in one questions, I implement several techniques. Okay. In one questions, I implemented several techniques. Do you need to try some questions yourself? Okay. So the 1A is without modulus. The 1B is with modulus. When it involved with modulus, everything become harder, as you can see. Just now the question that I did is question 8. You can try from question 1. 1B question 1. You can try first. Later, if let's say you got it, you can actually snap a picture, send to me, and we can actually discuss about it. Okay, let's see how some of the people's working. This one, 1B, question 3. Question 3, we have about this, and lesser than 9. Okay, so you, in order to make it equals to 0, okay, in terms of working wise, please write another line. Let, okay, modulus x minus 2, x plus 6 equals to 9. Please, okay, you have to make sure that you write a proper working. Okay, you have to please make sure that you write another line here. Then after that, I can see that you put it the plus and minus, then you should bring it to the other side. Okay, so you have x equals to 3, you have x equals to negative 7, then you have answer that being accepted and rejected. Okay, 3 here, so 3, 1, 9. May I know why do you reject this x equals to 3? This x equals to 3 is accepted. It's not rejected. How do you actually reject and accept?
Sir, when I substitute 3, I get equals to 9.
Equals to 9, so equals to 9. So it's
Oh,
accepted.
we do with the one we created, is it not the top one?
You when you do checking, you do it with equal first.
Oh, with the equal one.
Mm.
Okay.
When you
Okay.
do checking, you do with the equal first. Because you didn't do any inequality yet. You haven't do any inequality yet.
Yeah. Then that one also is accepted. The negative 7.
Negative 7, so negative 7 this equals to this, so this one accepted. What about here? Is it accepted, rejected? Let's see. So modulus of negative 2 plus square root 7 minus 2, okay, negative 2 plus square root 7 plus 6. So this one also accepted. The last one, this one also accepted. So they are all accepted. Since they are all accepted, you draw a number line. There are 4. Okay. So what are the values? Okay, 3, negative 2 plus square root 7. What is this number? Negative 6 point something. 0.6. So the first one is 3. Second is negative 2 plus square root 7. Then minus, this is what number is this? This is a negative 2 minus square root 7. Then this is a negative 7. This is the time that you do your inequality. This is the time that you do your inequality. So does it lesser than 9 or not? So you do with your test point. Okay, continue testing. Try. Okay, so if you continue looking for it, 8, 0, 0, this one should be fail. This one is not, this is not true. Therefore, you only have these two answers. This is not true. You substitute 0 inside the inequality. 0 minus 2, yeah, minus 2. Okay. Wait. You use 0. Oh, this is not 0. This is you shouldn't use 0. What the number is this? Negative, let's see, 0.6. 0.6. This is negative 0.6. I think you used the wrong number. Seven minus 2. Oh, this is positive 0.6. Okay, positive 0.6. To 3. Why this one is correct? Let me draw the graph and see. Modulus of x plus x minus 2, x plus 6 is lesser than 9. So I have a graph of 6 and 2, negative 6 and 2. The middle, this is a 3, negative, not 3. The middle is negative 6 plus 2, negative 6 plus 2 divided by 2, I have a negative 2. Okay, then this one is bracket negative 2 minus 2, negative 2 plus 6, I have a negative 16. More. Then after that, modulus. This one becomes 16. This one is negative 2. This one negative 6. This one is a 2. This one is a 12. And you have a 9. Okay, so this one is out. You can see from here, this is not accepted. This is a y equals to 9. This is the reason why you need all the techniques, all the possible techniques here, including of graph transformation. Okay. So therefore, the thing, without spending more time, okay, this one I let you practice it. So in the end, what you really need is all of this graph transformation that you're supposed to be worried about. Okay, so for both of your P1 and P3, okay, there are some series of basic graph that you're supposed to remember. Okay, so you need to remember how to draw line, how to draw parabola, how to draw cubic type A, cubic type B, how to draw reciprocal graph. Okay, so how to do the square root. Okay, how to draw exponential graph, log graph. This one, 7 and 8, we will focus more later in the chapter 2 later. Then modulus x, which is what you're doing here. Then 10, 11, 12, 16, 17, 18 is in your P1. Then after that, 13, 14, 15 will comes to chapter 3 later. Okay, so of course you have so many different basic graph. Okay, you have come with the basic transformation. So plus 1 moving up, minus a moving down, plus a inside the bracket moving to the left, minus a inside the bracket moving to the right, k times vertical stretching or compress, k inside is the horizontal stretching or compress, negative fx reflection by the This is x-axis, the negative inside reflection by the y-axis, then 9 reflection by the line y equals x. 1 over fx is the important techniques for 13, 14, 15 later. Modulus, folding, okay, f of modulus x and f of negative modulus x. So therefore you have this transformation questions that maybe appear in your exam. Okay, for example, how do we actually draw the graph? This graph, you will see that, okay, we actually using P1 reciprocal graph, then we do folding. Then only we can actually draw the line. How do we actually draw this graph? Modulus of x minus 2x plus 6. We draw the quadratic first. Okay, I find out the minimum point, then only I have to do folding to actually get the graph and compare it with y equals to 9. So those are the graph questions that maybe appear for exam. Okay, so I'm going to send you a series of graph questions, okay, that for you to practice. Okay, let me see. Okay, I just send you questions. Questions can be appear in this way. So this is the question in the from the file. Okay, these are the questions from the file. Okay, so all of these, they are a bit of graph transformation questions. Okay, so together with the modulus. Okay, so you need to, so this one become a solving questions back to the modulus equation that we're dealing with before. In a separate diagram, sketch the graph with the equation of x plus 1. From this graph, since I already give you the shape of the graph, that will be nice. This is very, very nice. So plus 1 actually tells us that it's shifting to the right by 1 unit. So I will have the graph that look like this nicely with 0a, then this one become 2, this one become minus 2 for the A, question A. Nice. F of x plus 1, because moving to the left by 1 unit. If I have a modulus x inside, okay, so this is the new thing that you need to learn. This will be the new thing that you need to learn. So how do we actually do this? This will be, we delete or erase the left hand side of y-axis, copy and reflect right hand side to left hand side. So how do we actually get the answer? Delete the left hand side, so erase it. Keep the right hand side. Therefore, I have a b here. Okay, I have a 1 minus a, 1 comma a here. Then I have a 3 here. Copy and reflect right hand side to left hand side. That means I have a symmetrical. That give me negative 3 here and negative 1 and a here. The final answer for f of modulus x is this graph. Can you follow? Okay, good. Okay, so this B, question B, is your number 12. Is your number 12. So let me just write it again. Okay, so this one is, let me write it. Delete left hand side of y-axis, copy and reflect right hand side to left hand side. Then this one with the minus in front, minus inside, what does it mean? Delete right hand side of y-axis, copy and reflect left hand side to right hand side. That will be the working for these two, 12 and 13. Okay. Then after that, indicate clearly each sketch of the coordinate or any point of intersection with the axis. Okay. Given that fx equals to x minus 1 minus 2, find the value of a and b. So we want to solve the equations for finding the value of a and b by using graph transformation. Okay, b is when, okay, to find b is when x equals to 0, y equals to b. So since they already give us the equation that y equals to modulus of x minus 1 minus 2, so I have a b equals to 0 minus 1 minus 2, which is equals to minus 1. b equals to minus 1. Okay, for a is when x equals to 1, as y equals to a. So substitute inside, so a equals to 1 minus 1 minus 2, so it's minus 2. So a and b is done. Then the d, fx equals to 5x. So I have a modulus of x minus 1 minus 2 equals to 5x. What exactly is this question? This question is exactly whatever that you've been doing up there. Whatever that you have been doing up there. This is your questions. Therefore, your exam questions may not, if the question being nice, they ask you to solve this. If the question not nice, they give you something like this. So in the end, the question arises here is, do you understand what you're supposed to do? Can you understand? Okay, so with this, we split into two parts. The one with the positive, the analytic questions. Okay, the one with the negative. Open it up. Open it up. Okay, so for x equals to 3, x equals 3 over 4. Okay, then I have this one is 6x equals to, this is a minus 1. So x equals to negative 1 over 6. Then don't forget, I still need to do checking. Checking. So when x equals to 3 over 4, okay, modulus 3 over 4 minus 1 minus 2 equals to, press calculator, modulus, okay, x minus 1 minus 2, calculate 0.75, so negative 7 over 4. So for 5 of 3 over 4, oh, negative, sorry, negative, there's negative here, so a negative, this one also wrong, calculate negative 0.75, so 1 over 4, negative 1 over 4. So this one is negative. So negative 15 over 4. Of course, they are different. Reject. Okay. So when x equals to negative 1 over 6, modulus negative 1 over 6 minus 1 minus 2, negative 1 over 6, negative 5 over 6, 5 times negative 1 over 6 is negative 5 over 6. Same. So the answer for D is x equals to negative 1 over 6. It doesn't include the second answer. You only have one answer. Only one solution. This will be the difficulty of P3. So some students will say that, can I observe it from graph? Okay, if you're good in graph, then no problem. 5x. 5x, this is 5x, 5x. So 5x is actually look like this. Y equals to 5x. How many intersection points do you see? You only have 1 point. Therefore, it's only one answer. Consistent. You see that it's only one answer. The answer is on the negative side, negative 1 over 6. Consistent. Therefore, whether students can do graph or not also become a determining factor for P3. Can students actually score for the questions or not? Okay, so you can actually use the file to continuously do the questions. Of course, anything you also can text me as well. Okay. Actually, we don't really need to spend all the time until 5:30 unless you want me to continue with the next topic, or you prefer to do next topic on the Friday. Okay, so do you all agree that we actually stop here? Okay, so later I will post the link of the video to you guys. Okay, that's all. Thank you very much.